I'll share my screen. Okay, looks like we are set to go. Okay, cool. Hello, everyone. Andrea, first of all, thank you very much for giving us the opportunity to be here today. For everyone, hi, my name is Remus. I'm one of the co-founders of Neurolabs and the CEO. And together here today, we also have Radu. He's a project manager and UI expert at Neurolabs. First of all, it's a pleasure to be here in front of you. It's our very first webinar or meetup, and hopefully it's the first one in a series of meetups and webinars to come, because we are truly excited and passionate about technology and what technology can enable in the real world. And since you are here, I think you all share the same passion with us, and yeah, that makes us very optimistic when it comes to this meeting, because we want this meeting to be a success. But first of all, we want this meeting to be very engaging for you, informative, and interacting as well. Okay, quickly, let me run through Neurolabs. As Andrea mentioned, we are from Romania. At the moment, we have a presence in the UK and Germany as well. We build computer vision algorithms. We've been around for 3 years, and we are very excited to share with you what our key findings have been over the last few years and how we see the future of computer vision in the automation space. So it was very illustrative, actually, very helpful to see the results from the poll. I'm very happy to see that half of the people are familiar with object recognition. For the other half, don't worry. The plan is to quickly start by taking you through the very basics of object recognition. However, I won't spend too much time because we do plan to cover quite a lot today. We'll start with computer vision in general, then we'll move on to computer vision and object detection as it looks today in UiPath. And finally, we'll have 2 demos to walk through that we would like to share with you, because at the end of the day, I think we are all interested in see how we can get started using this technology. Cool. So computer vision, broadly speaking, computer vision is a subfield of AI that deals with algorithms that can extract information from visual inputs. And for visual inputs, think about anything that related to cameras, images, videos. Now, computer vision is huge. It's been around for a long time, and is one of the key ingredients that enables automation in many different industries. So industries ranging from automobile to healthcare, robotics, of course, manufacturing, but also more exotic or like newer applications that we start seeing in agriculture, recycling. However, one needs look no further than the RPA space, because in the RPA space, computer vision actually it's at its base, and we'll see how computer vision underpins the UiPath technologies. Okay, but first of all, we do have computer vision in UiPath, and actually, as I already mentioned, it kind of like underpins the entire technology. However, when we talk to people from the RPA space about computer vision, the first thing that comes to mind is really computer vision related to identifying different elements on the screen, and that can be the UI, or that can be if you think about some documents. That's in a nutshell what computer vision is for the typical RPA developer. However, what we want to explore today is what we call computer vision in the real world. Basically, that's pretty much any use case that involves an actual object. So you have a picture, you have objects inside the picture. What computer vision is really good at is telling you automatically what's inside the picture. And in a way, the goal here is to mimic the human vision, because ultimately what we want to do is to build similar solutions that are currently built in the RPA space for document processing and document understanding, but we don't want to be necessarily limited to the UI and to documents. So we like to call this, being able to go beyond the screen. Okay, so very basic stuff first. What it takes to actually develop a computer vision model. There are 5 core steps. It starts with gathering some data, preparing the data set, then the actual training on the model takes place. Once you have a model trained, you probably want to test the model before deploying it in a production setting. And finally, you want the entire cycle to continue. You want to continuously improve the model. Now, this is not necessarily specific to computer vision. This is pretty much the basic workflow for any machine learning model development. It can be, from different areas such as NLP or, yeah, it's not necessarily computer vision, but it applies to computer vision as well. Next, I want to focus actually, so if we go back, I mentioned there are 5 steps. I want to cover the first 3 ones, because the first 3 ones are the ones that take most of the time, and usually this is what prevents many repetitive visual tasks to be automated. And we will see why. So if you focus on the first 3 steps, the way computer vision, and here you will see, you will hear me referring to computer vision as object detection. Object detection is just one of the tasks, or like one of the things you can do with computer vision. Object detection it's pretty much in very simple terms, localizing and identifying every object inside the picture. And this is probably the most important task in computer vision, because if you think about automating some real world use case, then it all starts with being able, with the machine or like the algorithm being able to recognize what it sees, if you can put it that way. So today we want to focus on object detection. So the first 3 critical points, the first 3 steps, it all starts by taking a lot of pictures. Somebody has to manually label these pictures. So you have to draw bounding boxings around objects and say what each bounding box corresponds to. And finally, we have access to these specialized models these days. You've probably heard of deep learning algorithms, which are great, but they require a lot of data. And here, when I say a lot of data, for some use cases, we are talking about tens of thousands or even like millions of examples that you need in order to train a model that is really, really good when it comes to performance. You can already see why this process is a little bit inefficient, and it's actually for many use cases, this is highly inefficient, both in terms of the time it takes to collect and prepare the data, but also in terms of the costs associated with this. Here we focus on the first 2 ones, but for the last one, if you think about it, then training some specialized models might require some computer vision expertise as well. So even without that, just collecting the data and preparing the data to be ingested by these models, it's a very expensive process. Now, is there another way to do these things? And yes, the good news is that there is another way to do this. And we call this synthetic data. And it all starts with the game engines. Think about the computer games that maybe some of you play these days. We got to the stage where these game engines, so the same technology that is used to produce to build these games, the same technology can be used to build pretty much any real environment. And it's amazing how much progress this industry has made over the last few years. And we got to a level where it's pretty much, it's so realistic that it's almost difficult to distinguish the artificially, like synthetically generated data from the real data. And actually, so this progress in terms of graphics, computer graphics, is kind of like the key enabler for this approach. What we did at Neurolabs is really to make use of this technology and bring it to computer vision, bring it to the machine learning space, where we can programmatically generate, reconstruct any real environment. We can generate data as much as we want. And the best thing about all this is that you instantly have access to every single detail in the image. So you know automatically information about each pixel. So in a nutshell, you are able to circumvent this lengthy and laborious process. However, this comes with of course, with one big ask, and that is the ability to recreate these virtual worlds. But once you have that, you can have full access to the data set, both in terms of how big the data set you want to be, but also in terms of the diversity, right? And that's another kind of like completely different story when it comes to diversity of the data, but maybe we can cover that in another webinar. So what we do at Neurolabs is it's pretty much what I already covered. We start with 3D models of the real ones. We use these game engines to generate what we call synthetic data, and then once we have access to these data sets, we automatically train the computer vision models. And ultimately, this is very important from a industry perspective, because in this way, we are able to shorten the entire time to market, or like the entire time that it takes for a model to be developed and deployed in a real use case. And beyond that, you also end up with very accurate results, just because you have access to as much data as you want. Here you can see some examples of synthetic data for a particular use case. Here is the shelf monitoring use case in a supermarket. Okay, but now let's go back. Now that hopefully you have a broad idea about object detection and kind of what limitations there are today and how we try to address some of those limitations. Let me go back to UiPath, and let's see what we can find today in UiPath. Because as I mentioned today before, UiPath, it's true, it's in the RPA space at the moment. It's a lot about you know, kind of like back office, the automation of back office tasks, things that involve documents or any workflows on the screen. However, there is some functionality in UiPath related directly to object detection. So there are we have two main options here. So the first one is really to go directly to the AI center within UiPath. There we find some very basic functionality, but it is there. It's a very good starting point, especially for use cases where you don't need any, where you don't need to recognize any specific objects. So if you're talking about very generic use cases such as car or like people. And the other option is to look look into the tech partners that provide computer vision platforms as a business, but also they integrated some of their basic technology in the marketplace, in the UiPath marketplace. So here just a quick look into the AI Center, as I mentioned, it's there. It's pretty limited in terms of what you can do. You can only use, well, you can use something that's already pre-trained, so off-the-shelf model. It gives you object detection, which is both the localization of the objects and the labels of the objects. You can also train your custom model, actually. You only have one model available, but you can do it. However, you need to bring your own labeled data, because currently UiPath doesn't support the data annotation. Whereas the partners, we have the big one, the big names, Google Vision, Amazon, Microsoft. Currently, you can only use their off-the-shelf models, but as you might expect, their pre-trained models are a lot more powerful. They can support identification of thousands of different categories. However, what currently exists in UiPath is limited to label identification. So it won't necessarily give you the location of the object, like the bounding box. However, AWS Amazon Recognition provides some functionality there. So my colleague Radu, he will go into more details in a bit. Yeah, the other option for if you have a custom model, like a custom use case that goes beyond generic classes, then you, of course, you can go use the platform directly. However, integrating, once you develop the model on the vendor's platform, integrating the model into UiPath is not straightforward at the moment. Yeah, we will see that a bit later on. So I think that's it in a very, very quick overview of computer vision. What we would like to do next is to actually jump into some use cases. We'll tackle two different use cases. We'll start first with a generic one. It's really it's parking monitoring. Here we'll connect to a real-time webcam of a parking area, and the task here will be just to detect the objects, kind of like the generic objects, car, truck, people. Whereas then we'll also take a look into a more complex use case. Well, what's actually complex about use case is the fact that the objects that we're interested in identifying and locating, they are something that you won't find in a pre-trained model. So we want to give you a flavor of both different kinds of use cases. And yeah, I think now it's actually time to move on to Radu.
Okay, thank you, Remus. Hello, everyone. 1 second to share my screen. Okay, so for the first use case, we want to monitor a parking lot. To get the input images, we'll open a live stream camera, and we will use generic object detectors available in UiPath. From, as Remus presented earlier, we'll take a look at AI Center, Amazon, Google, and Microsoft capabilities. For AI Center, as you know, we have an out-of-the-box model, which is available in out-of-the-box packages, image analysis, object detection. Once you're there, you can deploy it and integrate it in your UiPath workflows using the ML skills activity. As a result, here we get a JSON response with all the details related to the identified objects. Other technologies which can be easily accessed, as I said, are Amazon, Google, and Microsoft. For all of them, we can use their custom activities, which are published on UiPath Marketplace. And there is a documentation on the UiPath website where you can find all the details about integration. What about neural labs? How we can integrate it in UiPath? Currently, to do this, we will use the HTTP request activity, and the only thing that we need is the API endpoint, which we can take it from the Neural Labs platform. Beside this, what we have done for this demo is that we have created a Python script which adds the bounding boxes, so we can have a visual representation of the results. Our plan is to create and publish custom activities in the UiPath marketplace in the future. And before running the robot, I would like to move to our platform, just to move the zoom. Okay, I'll have the zoom there. Okay, so at this stage, for this generic use case, we will use an out-of-the-box model. I will not go too much in details at the moment. We'll come back later and we'll go through all the facilities we have on our platform. So we already have the model here, a smart city model. And in order to check the performance, I have uploaded some images before. And here we can check the performance. So this will be the images, and we can see the predictions. Okay, once we are okay with the performance, we can we move to the last step, and we can deploy the model. I have done this before, so my model car detector is deployed, and I just need to copy the deployment URL. Okay, so once I have the URL, I've copied it here before, we are ready to start the robot. Okay, as I said, we will look at a live webcam. Here we have some advertising. Okay, here we have the possibility to insert okay, how many images we would like to take. For this presentation, we'll just take one. So the robot takes a screenshot and then starts the processing. And in a few moments, we will be able to see the results on, yeah, here in the logs. Okay, as you can see. Okay, so here are the results for most of the platforms. We have only a JSON file, so we can't visualize the results. But for AI Center and for Neural Labs, okay, we can also have a visualization of the results. So we'll go in the output, AI Center. Okay, so this is the original image, and here are the detected objects. Looks pretty good. And for Neural Labs, okay, so this was the original image, and here are the predictions. Also, another thing which I did was to save the results in a friendly format. So this is a CSV file where you can see like the object, the coordinates, and the confidence. As you saw, all the technologies returned information about the objects in the images. Results are not great, but they can be a starting point. So we can use the information for different use cases, like counting objects, sending alerts, monitoring different areas. So for this first use case, the purpose was to monitor a parking lot and to recognize common objects in an image. So we could do this by using the existing options in UiPath, and with some post-processing steps, we are able to build an automation solution. But how efficient are these technologies if we want to identify some specific objects, like products in a supermarket? And this leads me to our second use case. And for this use case, our purpose is to identify the Kleenex products on the shelves. Here in the image, you can see 5 types of products, and we want to recognize 4 of them for this presentation. And first, we will use the previous workflow to see, so with the same models, to see what we get. I have saved one image there, and we'll see the results in a few seconds. Okay, so almost ready. So as you can see in the right side, the results are not so good. And this is what we have expected, in fact, because we are using out-of-the-box models, which are limited to a certain number of classes. So what we can do in this situation? The solution will be to train a custom model, which can identify these objects. And let's see how we can do this. First, if we are using AI Center, we have the possibility to retrain a model. In order to do this, we will need a data set with labeled images. And as Remus presented earlier, the flow is quite simple. You get the images, you label them, and using a third party. An example here would be Supervisely, which is a platform where you can label your images. And once you have all the images and the labels, you can come back on in AI Center, you can create a data set. Then in the pipeline, you can retrain a pre-existing model. We won't do this for this webinar, but I will show you the full workflow in another platform. The big players in the market, Google, Amazon, and Microsoft, offer similar capabilities if you want to train a custom model. Today, we will take a look at Amazon Rekognition. Okay, here the first step would be to take the images. Once you have all the images, you upload them, and then you start labeling. So I have done this before, or like 50 images, and all of them needed to be labeled. Once we have the images labeled, we are ready to train a model. Okay, and I've done this before, and here are the results for this particular use case. The performance of the model is not so great, but we can get better results by bringing more data. And here we can see some test images with the performance. Okay, so as you saw, it's not difficult to train a custom model. But as Remus said previously, the challenging part is that we can't integrate these custom models with UiPath in a straightforward way. A workaround would be to deploy the model so that you can get an API endpoint and integrate it in the workflows using the HTTP request activity. This is the information can be found in the documentation, both for Amazon, Google, and Microsoft. However, we will not cover this today. So for this particular use case, our purpose was to identify some specific objects in an image. As we saw, using generic object detectors don't bring good results, and we need to train a custom model. To do this, we need a lot of data. Then we need to label it, and once we train the model, okay, we need to integrate it with UiPath. Okay, but how can Eurolabs solve this particular use case? So to see this, we'll move on our platform, and we'll follow all the steps. Okay, the first step would be to have the 3D assets. So we have them here. As you can see, you can add new assets, and there are various methods to get 3D assets today, and there's a whole industry growing, and we expect in a few years to be like a straightforward process, and just by using our phones to be able to create 3D models. Okay, once we have the 3D assets, we are ready to generate a data set. So we want to generate a new synthetic data set. We select the category, all the assets. Here we have the options to group them. Think about fruits, for example, or where you have fruits and vegetables, you can create different groups for all of them. Okay, once we have selected the assets, we are asked to select the scene. Supermarket is the most relevant for our use case, and here we give it a name, and then we generate. This process is not instant, so we'll not do it right now. I have done it before, so we can check the results. So starting from 4 assets, our platform generated 1,000 images and placed them in a supermarket scene. And here are the results. Okay, as Remus said, the objects are already labeled, so we are ready to move to the next step, which is model training. And to do this, we go at models and new model, we give it a name, we select our data set, and we have some parameters which can be adjusted. And once all the selections are done, we are ready to train our model. Similar with data set, we are not going to do this live. The model was trained previously, and we are ready to see its performance. And the best way to do this is by using a test data set. So beside the data set which I used to train the model, I have uploaded another data set with labels. And here we can see how we can see the performance of our model against this new data set. Okay, it looks good. So we are ready to deploy and use our model. In order to do this, okay, we are moving to deploy mods and deploy it. I've done this before, and I'll just copy the URL. Once we have the URL, we are ready to switch to UiPath. And as I said, okay, Neurolabs will use the URL in the HTTP request activity. Okay, just let me copy 2 more images to don't have only one in the input, and I will run the robot for this particular use case. Okay. So on the right, we can see the results, but the most easier way would be to visualize them. Okay, so these were the input images. And here are the predictions. As I said, for this use case, we had in scope for products. And here are the results. Also, we have the CSV file with the information in a friendly format. Okay, so for this particular use case, we saw how we can use the Neurolabs platform, and starting from 3D assets, we were able to generate a data set. Then we could train a model, deployed it on the platform, and in the end, we had the endpoint. With the endpoint, we came back to UiPath, and we use it in the HTTP request activity. Once we have the results, we can do wherever we want with them, and based on the necessary aspects in the use case, we can use this information. And with this, I'll give the stage to Remus. That was it from my side.
Thank you, Radu. Thank you very much. Yeah, I hope you all enjoyed this very quick walkthroughs. The main idea here is really not that much to go into details. Each part of the workflow that Radu presented can be the subject of an individual webinar itself. What we really wanted to do is to give you a flavor of object detection outside the screen, and actually to show you how easy it would be in a way to make take the step between the document understanding use cases to something a bit more object dependent. I do hope that you got an idea. We are very, very interested in actually hearing your feedback. And actually, what I would like to do very quickly is just to leave you with a few examples of use cases where we have looked into. So as I mentioned before, the technology itself can be applied to different use cases, ranging from industries such as logistics, the grocery use case, smart city, but then also, when you think about like supply chain, or actually a very interesting use case where we deployed the technology was in canteens, where we identified the food on the trays. So these are just a few of the examples that we looked into. What we are very interested in actually hearing your feedback and having you give a thought and see how, like, if there are any use cases you can think about that could benefit from this type of automation. And yeah, we showed you the platform. We are still quite early stage. We are looking for early adopters, and besides that, we also, with the help of Andrea, we set up a dedicated forum page in the UiPath community, and our goal is really to start start like a movement, or kind of like a community around this new-ish idea of object detection. And yeah, please feel free. I invite everyone to start using this dedicated forum. We are here. We are not necessarily experts. I would say we are all here together to learn and see how technology and object detection in particular can help us automate some of the repetitive tasks from the real world. And I think that's it from our side. Now, yeah, let's have some Q&A. Hopefully we didn't take too much of the time, and we can do Q&A, I think, for 20 more minutes, or like 15 more minutes. And after that, I think the plan is for some of you to like get together in some groups, try to think about some use cases, and then we all regroup and just exchange some ideas. And with that, I will ask Andrea maybe to allow people to ask questions, or how does it work, Andrea?
Yes, I just allowed everyone to unmute. They can also start video if they want. I can see a question in the chat. How much of the time are we able to reduce using synthetic data set?
Yeah, that's well, as hopefully not many of our answer will start with today. That's a question that really depends on the use case, right? But to give you a concrete example, we had the use case in the supermarket industry. We looked at 300 products. In general, if you think about it, you would need around at least, I would say, 100 different images for each product. So I would say at least one order of magnitude. So whatever would take you like 3 months, you can do it in 3 weeks or even 3 days. It really depends on the use case. And not just speed, but also in terms of cost, I would say.
So another question, can I get the object on live CC camera using UiPath?
So if I read this question correctly, Razu is interested in connecting the live feed of the camera, right, using UiPath. So that's pretty much what we did, I think, in the first with the first use case. But it's just that we used a camera that was publicly available on the website. But yeah, as long as you have a stream, that's where the UiPath comes in, because it allows us to connect different pieces in the workflow.
How quick is the analysis of the image from a live?
Again, it depends. As Radu showed in our platform, you can play around with some toggles when it comes to model development, and that really tells us what are you after? Are you after speed, or are you after super good quality? Because at the end of the day, intuitively, there will always be a trade-off between speed and quality. Similarly, between speed and the size of the model that you can use. The bigger the model, the slower it is, but the better the performance. However, it really depends on the use case. If you're only interested in a few objects which are quite generic, then it can happen in real time.
What is the license cost associated to this tool?
So here, I think the question is related to our license, to the Neurolabs one. Well, we have a tier-based pricing model. We have a free one. So for people that just want to try it out, play around a little bit, of course, you will be limited in terms of what you can do, not necessarily in terms of the full functionality, but more in terms of, deployment or usage. And then we have a tier, what we call for professionals. It's really a few $100 a month, but that really allows you to serve your, well, a few use cases, let's say.
Thank you. Next one, can we be able to differentiate the copyright of same products based on different regions with the help of these models? So can we be able to differentiate the copyright of the same product?
So is this related to like fake copies of the original product, or what exactly do we mean by copyrights?
So copyright of the same product based on different regions with the help of these models. So maybe products that are different in specific regions. I'm not sure.
So imagine this: as long as you can tell with your eyes the difference between two products, the algorithm can be trained to do that. Now, arguably, there are cases where you can say that the algorithm can do a better job than the human being, but we don't want to push it that much. So if you can tell the difference between the two objects, then the algorithm should be able to tell the difference as well.
Okay, perfect. Would that be beneficial if the idea is to use it for smart city to control the traffic lights?
Of course. So that's just one of the many use cases that could benefit from this technology. It's the technology itself could be very beneficial, but when it comes to something like traffic lights control, it's kind of like it's a project or like an effort that involves multiple components, right? So you can think about the object detection as being like one of the input into that process. But of course, is the critical input that you would need if you want to automate this process.
And what I would add here is that you can use the cameras. So instead of installing some hardware equipments in the road or stuff like that, you can just use the live stream from a camera. So this can be another good point for smart city use case.
Yeah, I think that's one thing that we haven't really emphasized during the presentation. But again, this is another advantage of using something like synthetic data, because you're not constrained to any particular environment, right? So in the end, I can train a model that works on many different types of cameras. So in a way, you can be camera agnostic. And in this way, you can use existing infrastructure without the need to deploy new hardware. Okay,
Thank
the
you.
next one.
Next one is, can we detect the object from car number on traffic?
Is this the license plate?
Yeah, I think so. Yeah.
Yeah. We don't do that just because this goes into the field of OCR, like character recognition. Is really the whole idea behind synthetic data, and our expertise is in using physical objects. Having said that, there is synthetic data can be applied to document data like writing or digits or things like that, but it's not our expertise. So we stay away from anything that doesn't involve physical objects.
Okay. So next one, you have pre-generated use cases like the supermarket model. How much time will it take for you to generate a new environment?
Yeah, that's actually that's a very good question, because that's critical. And what we plan to do is to take different industries, kind of like step by step. So right now, the main focus is on the supermarket one. However, we can come up with an entire new environment in a matter of days. So that's for something that's completely new. But as I said, in the very near term, we'll have already some predefined environments for specific industries. And here, what we have in mind is the manufacturing industry, logistics, but also what actually we want to do at the end of the day is to hear from you, and you know, in a way to let you guide towards the industries where you see this technology a good fit.
Is there a comparative study info with your product with Google, Amazon, MS? Can you share the link?
We have a comparative analysis done internally. However, we posted some of the results in our blog post. However, at this stage, we don't want to, you know, take any hard view against the other ones. So we have it internally. If you're particularly interested, yeah, please send me an email. I can share that with you, but we don't want to make that public right now. Okay. Yes, we'll follow up with more information about how you can reach out to us and how you can get access to the free version of the platform. We just recently released the platform that Radu showed you, and actually at the moment we are looking for what we call early adopters to sign up and give it a try. And I promise you, you'll get support from our side.
Mm. So I think the best thing to do is post it in the forum topic where we opened it.
Oh yeah.
There people will be able to. Perfect. I'll leave the link again a bit later on after we finish with the questions. Another one: can synthetic data set creation tool label multiple characteristics of the product? Example, Dr. Pepper can have characteristics like can bottle, carbonated drink color, etc.
Short story, yes. It really depends on how you how you arrange your data, like how you define your data. And if you remember, Radu in his showcase of the platform, at some point he talked about being able to merge some categories. Now, if you start from a very granular model, from very low level, you can build up an entire hierarchy. It's really up to how you define the synthetic data that you generate. If you're interested in just the object itself, the beauty of synthetic data is that you can you have access to information about every single pixel. So what's very popular also in computer vision these days is what is called like object segmentation. So when you are interested in detecting the surface, or kind of like the area of an object, not necessarily just the bounding box. And in that case, that leads to instance segmentation, which basically deals with identifying each parts of an object separately.
We still have 3 questions. So your license cost allows usage for all environments you generated, or in the future could be a price per environment machine learning model?
So the license gives you access to a certain number of ML models. Right now, these ML models are tailored, are restricted to what environments we have already generated. However, we also have an enterprise tier where we can build the environment from scratch. So with the free tier and the professional one, you can access models related to what's already there in terms of environments. But with the enterprise tier, we can build your specific environment. But you can see how over time, you know, the catalog of environments, or like the possibilities environments we will grow.
Okay, we have another one. Could we use Neural Labs platform also for further processing recognized images, objects? Example, after recognition of image in healthcare like X-ray, could we process the image with another custom machine learning model? Diagnosis of disease within the platform, or the platform is only dedicated for image object recognition?
So it is the latter one. The platform is dedicated fully to object recognition and some other computer vision tasks associated to that. We do have some post-processing steps, but again, they are more related to expanding a little bit the expanding or restricting a little bit the reach of the model. But for something like this, yeah, at least that's the current state of the platform. For a use case like this, what you could do is, actually to use UiPath and probably some other activities available within UiPath to put on, like, to connect with the results from our object detection models.
Could we use Neural Labs for sentiment analysis by recognizing a person's facial expressions?
No, no. There are a few reasons, but we prefer to stay away from facial recognition. We do like generic people detection, but we don't go beyond that.
Okay, and the last one. So advertisement is more and more focused on customized ads. Do you see a use case of synthetic data being more efficient on better recognizing things like race, age, gender that would help out ad industry?
Yes, of course. There are companies that do that focus entirely on humans and this particular types of detections. However, yeah, we are not going that way, and but synthetic data is used for those use cases as well.
Oh, I think we're done with the questions. I think it's great. We had many questions and very good ones. Another one. What is the goal of Neural Labs for 2021? The last one. This is the last one we take.
Well, it's actually a very appropriate question to finish the Q&A. Our goal is really to try to assess and to try to popularize the object detection that we are talking about within the RPA space. We know RPA, of course, it's a very trendy space at the moment. Everyone talks about automation, hyper automation, and we generally believe that at some point it will come the time when people will want to move towards automating this kind of use cases. What we want to do is to be there, to try to form a community around this, together to see what are kind of like the lowest hanging fruits in terms of use cases in the RPA space that we could together help automate, and yeah, together try to make this technology more popular.
Thank you so much for all the questions and for all the answers, for all the questions that you generated and for the answers. And now we'll go to the last part of our meetup, which is entering the networking rooms. So I would like to invite you to enter networking rooms. You can talk about what use cases you found for object detection during today's meetup, either in your field or of activity or in any other existing field that you might find interesting. We'll have 10 minutes of discussions, and then we'll be back in the bigger group to share the ideas. So one of you from the team can actually share the ideas either by talking or by writing if you don't want to talk. So I will make the breakout rooms right now. So we will have 7 breakout rooms. So we'll have 7 breakout rooms with 7 to 8 people in the room. 10 minutes, start. So you'll need to enter the rooms when you are invited into them. Okay, so we are back in the big room. I think it's all of us. How many remained? We're now 32. So thank you for taking the time to bounce ideas, and I would really love to hear the ideas that you came upon. So whoever wants to speak can just unmute and tell us the idea.
Okay, hi everyone, Krishnakant here. Can you hear me?
Yes, perfectly.
Oh, okay. So our idea is, basically by using the neural lab, as of now, we are analyzing the images, right? So what I'm thinking is we can analyze instead of analyzing the images, we can analyze a sequence of images. Like it will form an action. So it's a kind, it will form an continuous video. So that what we can do is, so based on the so by analyzing those continuous actions, we can come to one conclusion. We can judge whether a person is threatening any whether he is doing any violence, or whether he is doing some 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 actions, based on the so based on the human action, so we can analyze whether if he is threatening a person, or he is trying to kill a person, or he's doing any violence there. So so that we can raise the alarm in that particular area, or we can send a message to the nearby nearby police stations or something like that.
I'm not. I mean, it's interesting, but I don't have the the technical capacity to say if it's something doable or not. So maybe Remus or Radu can actually help me.
Hi. Yeah, it's definitely a very interesting use case. What I would say is that when it comes to action, you can think about like behavior, like detecting behavior of a person, or you can think about kind of like tracking that person, right, moving around something. So it's not very clear to me which one you had in mind. Is it like,
sorry,
so which use case did you have in mind? Like the one when the person would move around an area, or the one where you would actually try to detect the behavior, as in what the person is doing, sitting down, standing up, lifting?
It's a behavior of the person, and then say for example, okay, we will analyze the behavior of the person. At the same time, we need to detect whether the person is holding any weapons, like a gun or knife. Okay, so that we can particularly focus on those persons.
Okay, well, for that use case, actually, the way it works, and we also kind of looked into it a little bit, is to focus on training a model that detects objects of risk. So you can detect like guns, or you name it, knives, things like that. So it would be like much easier to detect the objects, the high risk objects, as opposed to detect the actual behavior of that person.
Yeah. Okay.
Shall it work on the moving objects, or need to work on the static one only? So if the object is moving, like in video, so it will work on that object?
Yeah. I wanted to reply you, but I think you were gone from the general chat. So I think your question was around being able to work with video frames. Straight from our platform, or if you will have to use something like UiPath to break down the video into individual frames. And actually what I said is that we have it on our roadmap. So in Q3 this year, we will have video, like algorithms dedicated for the video use case. But meanwhile, what you can do is to use something like UiPath to break down the video in individual frames. And this is, although it might sound like it's the same thing, it's actually not, because there are a different, you can use some specific algorithms that are designed for tracking the objects. as opposed to dealing with each individual image.
Okay.
Thank you.
Thank you.
Yeah,
Any other
thank you.
ideas that you got to discuss in the groups?
Okay, Andrea, so I have one more idea. It's another use case. So as of there is a pandemic going on around the world, right? So a lot of people are not wearing the mask, and some people are going in the vehicles. So they, maybe in the two-wheelers, so they are also not wearing the mask. So if the person is going in the on the road, if a person is walking on the road, so we can the police or authorized person can stop that guy, and then they can do they can take necessary actions. If they are moving on the vehicles, it's a bit difficult, right? To stop them. So what we can do is we can use the traffic cameras to take the to capture that person or to capture that vehicle, and then we can we can gather all those images at the end of the day, and then send them to the another process where we can use the OCR to read the license plate number, and then we can send the we can send the fine, or we can take necessary actions based on that.
Yeah, it's a use case that it's growing in terms of adoption. Of course, the first thing is really to detect the car, and then once you detect the car, you want to detect the license plate, and then once you detect the license plate, which you can think it's an object, then you can use OCR to read off the number on the
license plate number.
Exactly. What we have seen in general is that when it comes to like traffic system, it really depends. Well, the hardware, the images that you have available, the quality of those images is really important in terms of how far you can go in terms of extracting information from the image. Because you have you have the moving cars that can like bring an additional layer of complexity on top of maybe the camera not being positioned in the best setting.
Yeah, the best angle. Yeah. Okay, I get it. Thank you.
You're
Thank
welcome.
you. So we still have 5 more minutes to hear at least one idea. Don't be shy.
Andrea, what is your idea?
I didn't get to think about it. I actually got called by my toddler while you were talking smart things.
Hi, this is Manoj. One of the idea which we had been discussing in the breakout room was especially related to the pandemic, and to avoid the crowded public places. How can we ensure that there is a social distancing is followed? Those public places, to ensure those guidelines are followed and alert the necessary individuals to take some actions.
Yeah, that's another very popular use case, as you can imagine, especially during these times. And it really boils down to being able to identify accurately people especially in crowded scenes. And once you have the bounding boxes surrounding each person, then you can very easily work out distances between people, or count them, or like whatever you're interested in. It's a good use case. I can see it having many different applications. Again, it's about what kind of hardware you have available, because with some scenes, the crowds, with some crowds, people can get really packed, and it can make it a bit challenging. But it's a use case. For example, it's a very good use case for trying out something out of the box, for sure, because most of the pre-trained off-the-shelf models, they deal quite well with people, cars, and things like that.
Okay, thanks.
Okay, thank you. One last idea from someone else? Radu, I think you were in the room. Were there any ideas there?
Well, yeah, you have heard previously the other idea. One of the other ideas were related to, or pandemic. So check if the persons are wearing a mask, and another one related to COVID test. So to identify like the COVID test in the image and then to use an OCR. And another one was related to, again, to identify some objects and some particular characteristics of objects in different situations. So yeah, this was what we have discussed.
Pretty interesting. Soon we'll be able to have other ideas instead of Corona. Hopefully we'll be able to use that time for other great things. Hopefully. Okay, so we are just in time to end this this great meeting. Thank you so much, Remus. Thank you so much, Radu, and thank you so much, everyone, for joining and for telling us your ideas, for thinking about the subject. You are invited on the forum link that I left several times in the chat. I hope I hope you all accessed it. If not, I can leave it just one more time for everyone in the back. Okay, so we have the link there. You can join the conversation there. Remus and Radu will be there, myself included. Thank you so much. Thank you, Remus and Radu, for your presence, for your time, for your effort, and see you next time. Have a good day.
Thank you very much.
Yeah. Thank
and have
you.
a good evening. Bye.
Good day.
Bye bye.
Yeah. Thank you.